All right, we have another coding problem to talk through. Here we are given two strings, S and T. And the way that we get T is that we start with S and we just randomly shuffle around the letters, and then we add another random letter somewhere in there, randomly. So we have to basically just find that extra letter that was added in. And I'm going to talk through a couple different solutions because I find it interesting. But we'll start with the one that I find to be most intuitive, which is to use a dictionary. So basically we could start with the string S, make a dictionary out of it where we keep track of the number of times each unique character appears. And then once we have that, we loop through the characters in T and try to remove those characters from the dictionary. And eventually, because there was an extra character added in there, eventually we're going to get to a point where we cannot remove characters. We cannot remove the character from the dictionary. And that character that we cannot remove is going to be the one that we're looking for. Okay. So let's do this. We're going to start, oh, and by the way, I am writing this by hand because writing is supposed to be good for your mental learning and stuff, and I enjoy it. So I'm going to write this out and then we're going to code it. Okay, so we're going to create a blank dictionary called counts. And so then we're going to loop through the characters in S, and we are going to basically keep track of that additional character in the dictionary. And so what we're going to do is we're going to do this. We're going to do counts dot get. We're going to get car 0. We're going to add a 1. So one way that you could do this is you could just say that for character in S, if character is in counts, then do this. Otherwise, or if character is in counts, then you would do counts char plus equals 1. It's pretty straightforward code. Otherwise, you would instantiate it. So you would set counts car equal to 1. This line of code using the get function does that all in one line of code. I don't think it's particularly faster or anything. It's just sort of neater. So obviously if you're trying to solve this on your own and you forget exactly how to use the get function, then you could just do it the manual way. But I'm going to do it here because it's a little shorter and neater. So yeah, basically if the character does not yet appear as a key in the counts dictionary, then assign it to 0 and add 1, and then that's going to be the value. Otherwise, if it's already in the dictionary, then take that value and add 1 to it. Okay. Oh, and so the reason that we put 0 here is that so that if the character does not exist in the dictionary, we first instantiate it as 0 and then we add 1. Normally, you would want to instantiate it as 1, but then because we need to add 1 in the case that the key already exists in the dictionary, and so this allows us to do just everything at once. Okay, so that's going through S. So then we have to go through T. Okay, so for character in T, if that character does appear in counts, then we are going to so at this point, when you first start out with the dictionary counts, every entry is going to be at least 1. And so we can subtract 1 from it. So then we are going to counts character, and we're going to subtract 1. Because basically what we're doing is we're removing this character from the dictionary. We're removing one instance of this character from the dictionary. Now we want to make sure that this dictionary, we want to remove characters once their counts get to 0. So let's do that. If counts is equal to 0, then we're going to delete it. Okay, and then eventually we're going to get to a point where the character is not in the dictionary, and then that's the character that we want to return. And so just to think through this a little bit, so what are the conditions in which it would not be the case that the character is in counts? So first of all, it could be the case that this character is a character in T that never appeared in S. So that's like example 1 here, where we have ABCD and ABCDE, where E never appeared in S, the string S. So in that case, it's pretty straightforward. You just want to return the character. Now, what if it was like S was like ABCD and T was ABCDD? It could be the case that there is an extra character that was a character that already appeared in S. And so in that case, that's why it's important to delete the characters once their counts get to 0, because by deleting the characters once their counts get to 0, that allows this clause of returning character to apply in the case where that leftover character, that extra character in T, is a character that had already appeared in S. And so in both those cases, regardless of whether this new character in T, regardless of whether or not it already existed as a separate character in S, it's still going to return it. Okay, and so that's basically how you do it. And I guess it's worth, I don't know, I suppose it's worth mentioning, one thought that I had at one point was I was like, this seems, so it's sort of weird that you have this sort of yeah, I was wondering if you could simplify it basically by making a dictionary out of T and then removing everything from S, and then you don't have to like check if the character is in the dictionary, because if you're starting with the dictionary from T and you're just removing everything from S, then it's always going to be in there and you're always going to be able to remove it. And at the end of the day, you're just going to end up with, like, once you go through this process of deleting characters, you're going to end up with a dictionary which contains one single character. And that character is going to be that character that was left over, and it's going to have a value of 1 because there was one copy of it left over. So yes, that would remove this the necessity to worry about whether or not the character is going to be in counts. However, this actually performs worse, because what you end up doing in this scenario is if you make a dictionary out of T and then you remove all the characters in S, you're going to have to go through all of the characters in S. And so you're guaranteeing that you need to like go through every single character in S. Well, I mean, you'd have to go through all the characters in T and then loop through all the characters in S, and then you would return a value. However, in this scenario, you might not need to go through all of T, because it could be the case that like the first character you run into, like it could be, suppose it was like S was like A, B, C, D, and T was like E, A, B, C, D. then the first character you would run into, you would immediately see, oh, that character is not in counts, so let's just return it. And so there's, particularly if, in the case where that character in T does not appear at all in S, you get to stop this process early. And so it's actually faster to do this. That's just an aside, but I figured I would mention it because it's good to think about these sorts of things. Like, what if I did this process slightly differently? What would change? Would it be better? Would it be worse? All right, so well, let's go ahead and let's just do this solution first to show that it works, and then I want to move on to another solution, which I find interesting. So we loop through all the characters in S. We're going to instantiate it if it's not there, otherwise increment it. And then go through all the characters in T. If it's in counts, then we want to de-increment it. And then if we have incremented it down to 0, then we want to delete it. Otherwise, if car wasn't in counts in the first place, it's the thing we want to return. And we can just run this, see if it works. And let's submit it. Okay, so there we go. And that's the solution. So there is another solution that I want to go through. And so this one I found interesting, and it uses something different. It uses, let me scroll down. Okay, there we go. It uses bitwise operators. So basically, here's the idea. Let's say that instead of let's say we have like S and we have T. And so we want to find this extra character that's C. Okay, so what you can do is you can take these letters and you can represent them in binary. So I'm going to make this up because this is not how this works. 0, 0, 1. Okay, so let's say we had this and we want to identify, we want to find the binary that is associated with C. If we look at this table, one thing that we can notice is that for any letter that appears in both S and T, the corresponding numbers appear twice. And so basically, let's see here, I wonder if this would make more sense if C were like, let's do this. Okay. So what do we notice here? We notice that so in this first column, 1 appears 5 times. So it appears an odd number of times. Here, 0 appears an even number of times, and 1 appears an odd number of times. And in the final column, 1 appears an odd number of times. And so you can identify the binary of the extra letter by figuring out between 0 or 1, which one of those numbers appears an odd number of times in the column. And the way that you would figure that out is using the XOR operator. And so XOR is basically, let's see here, if you have, let's see here, 0, 1, 0, 1. Basically XOR, it will take in two arguments. You feed it in either a 0 or 1 and then another 0 or 1. And it will output a 1 if precisely one of those numbers. It will output 1 if the two numbers that were put in were different. So so XOR is a function of two variables. If you feed it in 2 zeros, it gives you a 0. If you feed it 2 ones, it gives you a 0. If you feed it 0, 1 or 1, 0, it gives you a 1. Okay. So then what you can do is you can like go through these columns and just do XOR all the way down. So like here, 0 XOR 0, that's 0. XOR 0 again gives you 0. XOR 0 again gives you 0. XOR 1 gives you a 1. And so your output would be 1. And then here, 0 XOR 1 would be 1. XOR 0 would be 1. XOR 1 would still be, let me think about this. 0 XOR 1, this is 1. XOR 0, that's still 1. And then you XOR with, because then at this point, the result is 1, and then you XOR with 1, and 1 XOR 1 is 0. And then you XOR with, and then you have 0, and you XOR with 1, and you get 1. Okay, and then you would do the same thing, and you get 1 again. Okay, so basically when you do the XORs, it cancels out like this. And why does it work? This works, an easy way to see this is that XORs are associative and commutative. So let's use, what's it? So in Python, it's the caret symbol is used for XOR. So A XOR B is equal to B XOR A, XOR B XOR C is equal to A XOR B XOR C. This first property is the commutative property, and the second property is the associative property. The way you prove this is actually brute force. You just test all the cases. For here, it's pretty easy because you could just look at the table. So like you just loop through every combination of A equals 0, A equals 0 or 1, and B equals 0 or 1. And you can also sort of see that by the fact that this table here is symmetric. For the associative, you have to check like 6 combinations because A, B, and C can each be 0 or 1. Wait, did I count that right? 2, 4, 8. It's 8. Yeah, it's 8. Okay. So you have to check a few more things, but you can check it and it's right. Okay, so given that it's commutative and associative, what you can do is you can take this. So let's say you have this A, B, C, and you want to XOR everything. What you can do is, let's see here, it's commutative, so you can like do A. Okay, let's write it like this. A caret B caret A caret B caret C. So what you can do is you can combine all the like characters. So it would be A caret B caret C. You can adjust the order because of commutativity. And then what you do is you can combine it like this. And then anything XORed with itself is going to be 0. Right? And so then this is just going to be 0 XOR C. And then 0 XOR anything is going to be itself. because 0 XOR 0 is 0 and 0 XOR 1 is 1. So 0 XOR anything is that thing. So this is equal to C. Okay, and so basically when you XOR all these things together, basically anything that appears an even number of times is going to like cancel out. And so once you do all this cancellation, you're going to be left with just the thing that's in T. And so this is the logic of how it actually how this XORing process works. But then to actually implement it in Python, the code is actually fairly straightforward. So we're going to start with our result. We're going to say it's 0. We're going to loop through all the characters in S. And so here is the syntax. So res caret equals ord car. Okay. So the caret equals means just like we're taking the result and we're XORing it with this thing ord car. Ord car, so ord it's short for ordinal. This is a function that converts letters into ASCII. And so basically you give it a letter and it gives it generates a unique integer for each letter, for each alphabetical letter. But when we're doing this bitwise operator, remember I showed above that I was using like ones and zeros. So bitwise operation works on numbers in binary. So basically, result is just 0. That's also 0 in binary. And then when we do the result careted or XORed with ordinal car, so the character is ord converts the character from letter to integer, and then in the bitwise operation process, that operation occurs in binary. So it's like it would like take that integer and convert it to binary and then do the XORing and then convert it back to an integer. Okay. And then for car in T, we're going to do the same thing. And then we're going to return cur res. Okay, so why are we returning Chris? So cur is character, so that's a function which converts a integer. It converts an ASCII integer back into a letter. So it's just undoing the ord. Okay. So yeah, so this is what happens. And by the logic that I explained before, basically anytime for every element that for every character that appears in both S and T, the effects of those elements on the result are going to cancel out with each other. And so the only thing left over is going to be the final result. And so we can actually test this out. So we're going to start with the result equals 0. Here in S, we're going to do the bitwise operator with ord car T, bitwise operator ord car, then finally return cres. And you can run it. All right. All right. And yeah, there we go. And so that is, yeah, that's 2 ways of doing this exercise. And so the second one is, let's see here, it performed better as well. I believe that bitwise operation just like runs faster in general. Yeah, even if it doesn't, like the code is cleaner, and I think it's just sort of neat. But yeah, so there's sort of like a straightforward way of solving this exercise, and then a sort of interesting, unique way of solving it. And there you go.